Welcome back my fellow plastic menders to 3D pen crafts made easy. My name is DK and today we will try to explore our way to produce a thin and straight strand of filament. Let's get prepared and get going. The way that I would like to achieve this type of strand of filament is by using the 3D pen to automatically feed and produce it. The nozzle of the 3D pen is a lot thinner than the 1.75mm filament, and thus we should be able to use that fact to our advantage.
Too late, hombre.
Cutting the filament seems a bit tricky as the filament is rather elastic and didn't want to be easily cut. Trying to lay down the filament is too inconsistent and definitely doesn't produce the right results. Picking off each single strand produces the results, but is rather time consuming to produce the strands. So I realized it would all be much easier if I could have both of my hands free to be able to continually retrieve the plastic while it is being produced. So I have clamped my 3D pen to my lighting rig and set it to automatically feed. Instead of cutting, I will try to use the torch lighter to separate the strands. So far so good. I was tricked by the first success. A piece of molten plastic decided to try and fuse with my thumb. Aside that, the filament strand has caught on fire. Only a fool would continue this. Scaredy cat. Sometimes that is a great thing to be, as that made me invest my hope in the flush cutter once more. Cutting it a bit further away from the nozzle seems to be working a lot better as the plastic is more solid and prone to be cut. I have cut the thin filament to length as well as the straightened original filament from our previous test. Let's connect the filament together and prepare them for the oven. While we are at it, let's add a pen sheet as well. After completing the sheet, hold it up and fill in the minor gaps that didn't get filled properly. This to avoid having holes later after baking these charcoal cookies. I planned to do a temperature ramp up to see the different results, but forgot to make clear shots of the results. Guess I was too into baking that I actually ended up with the charcoal cookies. Or maybe I was too eager to get the cookies. This result came to be at 230 degrees Celsius, so I was curious to see if I could melt it back down at a lower temperature and get a better result. Apparently it's irreversible. That clearly invites for a retry. So I quickly made a stack of thin filament for a second attempt, which can clearly be seen by the thicker line on the sides. Only the one on the top left did not get a connection. At 170 degrees Celsius, the test came out really nicely. The gap lines on the sheets is due to the lack of material, as the filaments do provide space in between. This is something that I want to continue to research and improve for the next time. After increasing the temperature to 190 degrees Celsius and melting the sheets again, the gaps and thickness of the sheets have increased a slight bit in size, while as the connection lines have flown to decrease in size. I am no chemist, but it seems as if the molten plastic show a lot of cohesion, just like water first creating a dome above the rim of a glass before overflowing. After another increase, this time to 210 degrees Celsius, the plastic clearly demonstrates its cohesive properties, which, aside that the plastic irreversibly changes after baking it, in turn provides us with information that melting at the lowest possible temperatures might be the best aim to go for, Suggestions, questions and requests are all much appreciated in the comment section down below, and I will try my best to reply and perhaps follow it up in future content. If this seems to be the channel that you would enjoy, please consider a like, share and subscribe, and join me in making some fun crafts. Thanks for watching and happy bending everyone.